So as we have talked about the relational database management system as a set of programs that enable interaction with relational database using SQL, let's talk about some of more features of this relational database. Number one is that it organizes the data into rows and columns, collectively forming tables where data points are related to each other. The rows and columns are similar to that of MS Excel or Google spreadsheets as you have seen, but we form tables in the relational database and rows and columns in the Excel or spreadsheets are just flat files. The data is typically structured across multiple tables which can be joined together. And how the data is joined together is through keys. Keys demonstrate the different relationship between tables, and we can use the data models to visually represent those relationships. Analysts use SQL queries to combine different data points, summarize the business performance, and gain insights. The most important feature of the relational database is its ACID properties. Relational databases are associated with transactions, and ACID properties refer to a set of 4 guarantees that ensure the integrity and reliability of data in those database transactions. These properties are crucial for maintaining data consistency, especially in situations where multiple users or processes might be modifying the data simultaneously. So the A in ACID stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Let's talk about each of them in detail. First is atomicity. This ensures that a transaction is treated as an indivisible unit. Either all the operations within that transaction succeed or none of them do. This prevents partially completed transaction from leaving the database in an inconsistent state. Let's take an example here that you're transferring money from one bank account to another. So either the entire transaction, debit from one account and credit to another succeeds, or it fails completely. If it fails, the amount is instantly refunded to your account. There is no partial transfer in between. The second property we talk about is consistency. This guarantees that a transaction moves the database from one valid state to another valid state. The database enforces data integrity rules and constraints to maintain consistency. Let's take an example. A transaction might involve transferring funds between two accounts. Consistency here ensures that either both accounts are updated successfully or neither is affected. And another example could be that if a student enrolls in a course, the total number of enrolled students should match the course capacity. In this way, we make sure that the database is always consistent. The third property is isolation. This property ensures that concurrent transactions are isolated from each other and don't interfere with each other's data. Even if multiple transactions are happening simultaneously, the result should be the same as if they were executed one after the another. So a typical example I am showing here is that two users are simultaneously booking tickets for the same flight, so they should not interfere with each other. Each transaction should be isolated until it completes. And if one user updates the profile with another user while another user views the same profile, their changes should not overlap. The last and fourth is durability. This property guarantees that once a transaction is committed or marked as successful, the changes are permanently stored in the database, even if a failure occurs in the system after a commit. An example is that after a successful online purchase, once you have placed an order in an e-commerce site, the order details are stored permanently even if the server crashes. Or if a user updates their password, the new password remains valid even after a system restart. These four are the pillars of any relational database, and the ACID properties are at the core of Rdbms's. In summary, atomicity means all or nothing, consistency means valid state before and after, isolation stands for concurrent transactions don't interfere with each other, and durability stands that the changes persist even after failures occur, even at the system level. I hope you enjoyed watching this video. And let us see you in the next lecture. Thank you.